Let's talk about Boolean values. Now, a Boolean value is simply a value that is either true or false. A Boolean expression, then, is an expression that returns true or false. And we use such values, such expressions, in programming a lot. We especially use them to control whether or not we're going to execute the code associated with an if statement, for instance, or whether or not to continue iterating on a loop. So they show up all over the place. It's important, then, that we understand how Boolean values are stored, how they're interpreted, and ultimately how we can work with and manipulate Boolean values in our code. So first, let's talk about how they're stored. Boolean values in the C programming languages, or C family of programming languages, are stored as a number. And the numbers that will immediately jump into people's minds when thinking about true and false are typically 1 for true and 0 for false. Now, this isn't wrong, but it's also not the whole story. So it is accurate to say that a 1 is considered to be true in C, C++, and so forth, and that a 0 would be considered false. But since a 0 is false and true is not false, is it then accurate to say that not 0 is true? And the answer is yes. So said another way, 0 is false and anything else is considered true. So that's an important detail that we need to be aware of under the hood, because assuming that a value will only be considered true if it's a 1 can lead us into some problems. Okay? So again, Boolean values are actually stored numerically by the computer under the hood, if you will, and a 0 will represent a false and anything else will represent a true. Okay, so that's actually both of the issues of how they're stored and how they're evaluated. Now we need to talk about how Boolean values and Boolean expressions then can be manipulated and used and so forth within our code. So the principal way that we will do this, that we will work with and evaluate Boolean values, is with these operators. So on the left, I've listed the comparison operators that we can utilize to perform tests between two values and then get a truth value in return. Let me say that another way. So here we have the greater than operator, and what it does, it's a binary operator, so it takes two operators, and what it does is it compares the I think I just said that it takes two operators. It takes two operands, So what it does is it takes the operand on the left and checks to see if it is greater than the operand on the right. And if it is, it returns true, and it returns false otherwise. Less than works similarly, but it's checking to see that the thing on the left is smaller than the thing on the right, and it will return true if that's the case and false otherwise. We also have the equality operators. This one you're probably familiar with. It's one of the first things we often work with when we're learning to program, and it's just the equals to operator. And it checks to see that the thing on the left is equal to the thing on the right. If so, it returns true, and otherwise it returns false. Not equal does the opposite. It checks to see that two things are not the same, and if they're not the same, it returns true, and false if they are the same. We can also combine these comparators, greater than and less than, with the equality operator to create kind of a hybrid expression where we say greater than or equal to or less than or equal to. And as hopefully is already becoming obvious, then this would check to see that the thing on the left is, for instance, greater than or equal to the thing on the right, in which case it returns true. So these comparators can be used to generate truth values based on relationships between variables and values in our code. Now, this is great and this is extremely useful, but sometimes we need to do more than one comparison or compare something to more than one thing. And one way of managing that could be to nest multiple if and if-else statements and so forth, but that can get really complicated really quickly. And so another approach that we can take that is often more appropriate is to create a complex expression that combines multiple comparisons and so forth by using these Boolean operators. So let's talk about them for a moment. We have three principal Boolean operators, and, or, and not, and their names suggest what they do. The first two are binary operators. They take two operands. And the last one is a unary operator. It just has one operand. So let's talk about the first two. What the AND operator does is it looks at the expression to its left and the expression to its right. So an expression could just be a constant value, it could be a variable, or it could be an expression that utilizes one or more operators, such as these over here. And so it looks at the expression on its left and the expression on its right, and it tests to see if they are both true. So if the thing on the left and the thing on the right are both true, then this operator will return true. In all other conditions, it'll return false. So if the thing on the left is true and the thing on the right is false, it returns false, and so forth. The OR operator works kind of the other direction. If either expression on the left or the right are true, or both of them, then it will return true. The only situation in which this operator will return false is if both expressions are false. Okay? Now the final operator is, again, this unary operator, the NOT operator. And what it does is it looks at the expression to its right and it inverts the truth value of that expression. So if the thing to the right is true, i.e. non-zero, then this operator would return 0. And if the thing to the right is false, then it would return true. It just flips it and gives us the opposite truth value. So let's look at some code that demonstrates the usage of these operators, and that'll help to solidify the way that we can do all of this. To some code. All right, so this is a simple program that simply suggests a set of activities that can be performed based on the current weather conditions and time. So here you see I'm creating several Boolean variables, and a Boolean variable is simply a variable that can store a Boolean value, true or false. And we have this convenient keyword false, and there is a corresponding keyword true that we can use to represent these ideas. So while we could use ones and zeros and so forth, that's not very readable and is easily confused. So it's much better to use the keywords for the truth values when we're working with Booleans. So I have here, let's see, 1, 2, 3, 4 different weather conditions: sunny, windy, warm, raining. And I've initialized them all to false, and we'll see why I've done that in a moment. Then I have a variable just to store user input. I'll be reading characters, so it's a char. And I've also created an unsigned int called current hour. And this will store the hour in military time, or in other words, 24-hour time. And we'll use that to make some decisions later. So again, this will be a value between 0 and 23. It will not, we won't go, or excuse me, we won't say, for instance, 1 p.m. That would be 13. And we won't mess with, minutes, half hours and things like that. We'll just deal with hours here, and this is all just for the sake of simplicity. Okay, so the program says welcome, says what it's going to do, and then it begins asking some questions. Let's run through it, get a feel for what it's doing, and then we'll talk about the code that actually implements this behavior. So, all right, welcome. This program will suggest things to do based on the current weather conditions and time of day. What hour is it in military time? So I'm going to say that it's 8 o'clock. Okay, is it sunny? And we'll say that yes, it is sunny. Is it windy? No, it's pretty quiet out. Is it warm? Definitely. And is it raining? No, not at the moment. You could read a book, go jogging, play frisbee, or go swimming. Okay, so this is the idea of the program. It just gives us a list of things to do. Now let's look at where these activities are coming from and the decisions that are going to be made, and then we'll look at the code that actually implements those decisions. So let's jump back in and look at this chart that shows weather conditions. Okay, so here we see I have several activities: frisbee, swim, jogging, read a book, or sit by the fireplace. So 5 different activities that this program could recommend. Now you'll notice sit by the fireplace shows up twice, and that's because there are 2 sets of conditions under which we might sit by the fireplace. Okay, and the weather conditions and the time are listed across the top here then, and so each of these columns corresponds to the requirement relative to that condition for us to be able to do the activity. So let me explain. So when I look at frisbee and I read across this row, I see that this question mark indicates it doesn't matter if it's sunny or not. I'm not concerned about that when I'm deciding to play frisbee here. Now, wind is a problem, and so in order for me to play frisbee, it must be false that it is windy. Again, I don't care if it's warm, and it must be false that it is raining. In other words, if it is not windy and it is not raining, then I'm willing to play Frisbee. Okay, and so that would be something that should be suggested. Now, we've also added this notion of the time of day, and we're going to factor that in. Initially, we'll see that the program isn't considering time of day, and that's one of the things we'll look at, is adding that as a consideration. But we're suggesting here that it must be after 6 in the morning and before 20, which if you do a quick little bit of math, you see that that's about 8 p.m. No about there. It is 8 p.m. And so between 6 a.m. and 8 p.m., those are the times that we're saying we'd play Frisbee. So if these things are met, these conditions, it's not windy and it's not raining, and the hour is greater than 6 and it is less than 20, then we've met the conditions for playing Frisbee. Okay? So for swimming, we're saying it must be sunny, not windy. It must be warm, not raining. And we're looking for hours that are greater than 11 and less than 18. So 18 would be about 6 p.m. So we're kind of aiming for the middle of the day for swimming, which makes sense. Jogging, we don't really care if it's sunny, windy, or warm, but we don't like to jog in the rain. So it must be false that it is raining. And in terms of time, again, between 6 and 20 hours. Reading a book, you'll notice I've got question marks all the way across here. And so this is indicating we don't care what the truth values are for these different variables. We're saying we'll read a book anytime in any condition. So that's a valid suggestion at any time. Okay, now sit by the fireplace. Again, this has two rows, and we'll talk about it. So this first row says that we'd sit by the fireplace if it is not sunny, it's not warm, and it is raining. So if there's a storm outside or whatever, then, hey, let's sit by the fireplace. That might be an enjoyable thing to do. Now, at the same time, there's this second option, which says sit by the fireplace, and all these things are question marks. We don't care for this row about the sun, the wind, and so forth. But we are saying that the time is greater than 22. In other words, we're saying, is it after 10 o'clock at night? And that makes a little sense too. If you get late enough into the evening, it's kind of fun to sit by the fire, regardless of what the weather is outside. So this has created an or. So you'll notice there's an and relationship between the hours that we're considering here. And now we're creating an or relationship between this set of conditions and this set of conditions. So if it is not sunny and not warm, and it is raining, then we'll sit by the fireplace, or we're willing to sit by the fireplace. Or if the time or the hour is greater than 22. Now, I should probably make this greater than or equal to 22, because that's more of what I was thinking, that, hey, if it's 10 o'clock or later. So let's make that quick change. So we'll say greater than or equal to 22, and we'll go on from there. All right, so nothing too earth-shattering here. We're querying the user and saying, hey, what hour is it, and storing that. And then we start asking questions. Is it sunny? And based on their answer, yes or no, we'll then store a truth value in the associated variable. So if they say yes to the question of is it sunny, then we set is sunny to true. And you'll notice that's all I need to do. I don't need to worry about an else and setting it to false, because up here where we initialized our variables, we said is sunny equals false. So we began with the assumption that all of these things are false. And the user's responses have the potential, there we go, to cause us to set them to true. So that's kind of the scheme we're going to use here. So we ask about it being sunny, and we ask about it, I'm having difficulty today, there we go. We ask about it being sunny, about it being warm and raining and so forth, and we convert their character response into a Boolean value that we store in a variable. Okay, so we're going to see here that that's actually really useful, because now instead of needing to store this character and decode it every time that we want to talk about whether or not it's windy, we just have this Boolean variable that we can already use in Boolean expressions anytime we need to from here on out in the program. So here's where we actually start to print out the list of activities for the user. So it's a simple cout statement. You could, and you'll notice that I put read a book automatically. Why? Well, because when we looked at the table on that previous screen, we saw that it didn't matter what the weather conditions were. Reading a book was an option. So no need to think about it here. Always suggest it. So that's what's being done. But then we get into actual decision making concerning the different activities. So here we ask, is it raining or not? So if is raining is not equal to true, because you'll remember we said the condition under which we would go jogging is that it's not raining. That's the only thing we cared about, is that it wasn't raining. And so here I'm comparing the Boolean value stored in is raining to true, and I'm saying that I would like that to not be the same. In other words, I want is raining to be false. And if that's the case, then we will list go jogging. Okay? Now, another way that I could have represented this expression or gotten the same effect would be to simply put the not character, and you already saw that this works correctly as it is. We were suggested, it was dealt with properly. We were told we could go jogging when we said that it wasn't raining earlier. But this is just a simplification. We could get away with just using the unary operator not, and then the variable is raining. So if is raining has true in it, meaning that it's raining, then the not operator would return false, and that would be the value of this expression. And so that would cause us to not suggest jogging, which is what we want. If is raining is false, then this not operator will return true, which would say, hey, then if it's not raining, we will go jogging, which is what we wanted. So this is just a different way of getting the same result. It's also quite readable. If not is raining, if it's not raining, go jogging. And so it's not only concise, but it's also programmer friendly when they see that. So you might consider doing that to simplify such expressions in your code. Okay, let's look at some of the others that we have here. So we dealt with jogging. Okay, so now we're considering Frisbee. This gets a little bit more complicated. With Frisbee, we said that it had to be the case that it was not windy and it was not raining. And then we have this time thing again here. But I'm actually going to leave much of dealing with that to you. I'm just going to, as a simple practice exercise, I'll just introduce the idea and then set you loose on it. So for now, we're just considering these weather conditions. So here we're testing just what we said. We're checking to see that it is not windy and that it is not raining. So if both of these expressions evaluate to true, then we'll suggest playing Frisbee. Again, behavior that we wanted. Finally, sit by the fireplace. Shouldn't say finally, I think we had one more. Yes, okay. So sit by the fireplace. Now here we're checking three different things. So not is sunny and not is warm and is raining. Now let's consider the issue of time. So let's jump back over where we saw that we're only willing to play Frisbee when the hour is greater than 6 and less than 20. So let's add that as a condition so that we're not playing Frisbee at midnight, no matter how good the conditions are. So Frisbee, not is windy and not is raining. Okay, now let's add in also then the issue of time. So we want to see that it's not windy, it's not raining, and the current hour, we said that it needed to be greater than, need to double check, I think we said 6. Yep. Okay, greater than 6. That's a 7, Frank. There we go. We're tempted here perhaps to say, and it must be less than, we said 20. There we go. We're tempted to say this, current hour greater than 6 and less than 20. This isn't going to work because what we're trying to do then is the computer thinks we're trying to do an and on a less than 20. That doesn't mean anything to it. So it sounds like good English. We understand what is meant, but we have to actually be much more explicit. What is it that we're trying to compare the 20 to? It's the current hour again. Okay, so this would be the proper way to compare these, or excuse me, to combine these two comparisons. Current hour less than 6 and current hour greater than 6 and current hour less than 20. Now this is getting a little obnoxious. We've got so much going on here. The line is getting long and so forth. So at this point, we really might want to consider going on to a new line and starting to use parentheses more judiciously. So for instance, I think of the issue of the weather as all kind of being one thing. I'll just do this, that I consider, that it's not windy, it's not raining. So those are kind of the weather issues that I'm looking at. Then I might come here and maybe hit a new line, make it a little more readable, tab that in. So it's not windy, it's not raining, and then I might put this expression in parentheses so that it also stands out as its own set of issues. There we go. Okay, so now I can kind of more easily see that I'm looking at the hour as an issue, and I'm looking at the weather as a separate issue. Okay, so hopefully that makes a little bit of sense. And if all those conditions are met, then we'll suggest playing Frisbee. Okay, so let's see if this works and if that eliminates the Frisbee option if the hour is late enough in the day. Oh, I have an error. Current hour, unsigned int. What do we have here? Undeclared identifier. On line 50. There we go. I've got an extra A sitting here. So current hour, etc. That looks better. Let's run that. Okay, suggest things to do. What hour is it? Now we're going to go ahead and suggest something past the point that we would want to play Frisbee then. So we'll say it's hour 22. Is it sunny? No, it's dark. Of course, let's see, with Frisbee, yeah, we didn't mention the sun, so this will work. So is it sunny? No, it's not sunny because it's dark. Is it windy? No, it's not. And so that was one of the conditions. We said it can't be windy and it cannot be rainy. We're going to say it's not warm and that it is not raining. So if we were ignoring time, then we would have met the conditions for playing Frisbee. But we are considering time now. You could read a book or go jogging. And so you see that the Frisbee option has been left off the table. So we're successfully considering it. Okay, so with those ideas in mind, I would invite you to maybe finish this program. The code will be made available to you, and the ideas that you've been shown should be enough that you could finish it up and make it so that time is factored into all of these different options. And a little bit of a challenge is to also figure out how to use the OR operator then to deal with the sit by the fireplace option, and the fact that there are two ways that the conditions for that could be met. And make sure to do it without using two ifs. So that's the challenge for you, is in one statement you should be able to consider, in one if statement you should be able to consider both sets of conditions that would satisfy the requirement for suggesting sitting by the fireplace. All right, so good luck with that. Thank you.